Hello everyone. So this is Sudhir Gupta and today I will be explaining you the first experiment of your BSc first semester lab, and let me check the object of this experiment. So it says here is the manual. Its object is to determine the value of J using a bar pendulum. So you could see actually as it says over here, the apparatus that we require are the bar pendulum, which is fixed over here by means of a knife edge, and then the second thing is the stopwatch, and here is the stopwatch I just issued, and then the third thing is the meter scale. You could see it over here. Okay, so now let's see actually what we want to do over here. We want to determine the value of acceleration due to gravity using this bar pendulum. So I believe all of you have seen the calculations related to the bar pendulum during your class 11th or 12th, and if not, you would have actually an exposure to this thing in your theory class for the mechanics. Okay, so what we want to do, so here is the formula. As you could see, T is equal to 2 pi square root L by G, where L is the distance of this bar pendulum, length of the bar pendulum from the knife edge to the end. Okay, and G is obviously the acceleration due to the gravity. T is the time period of the time period taken by the bar pendulum. So from here, if you just square it, you will get G is equal to 4 pi square L by T square. So this is the formula that we require to use, and clearly according to this formula, if we could measure the value of 4 and the time L and the length and the time period, we should be able to get the value of acceleration due to the gravity through this formula. So let's now discuss how do we perform this experiment. In fact, not only discuss, I would show you explicitly how to perform this experiment. So what do we do? You could see, in fact, here we got lots of hole around this bar pendulum. So we will first hang. So here is the bar pendulum. Let me just show it to you, so that you could have a full picture of this thing. Okay, this is nothing but it is just a bar which has got actually lots of hole, and it has got an end where you could actually put these sorts of bolts, and which you could use to hang it through the knife edge out here. Okay, so I had hanged it over. So now what you would do, you should first measure the length of the pendulum from the knife edge up to the end. Okay, so for example, here you could see that this length is let me check it out here. So this is about 36.23. Okay, so this is 36.3. Now what we will do, we will fix oscillations. Okay, in fact, and then we will try to fix actually a point with respect to which we will oscillate this pendulum, and would try to count the total time taken by a fixed number of oscillations. We will later divide it by the total number of oscillations. That would give you the period or the time period or the time taken by the bar pendulum for single oscillation. Okay, at this particular length. In the next step, what we will do, we will reduce the length. Okay, that is, we will fix this bolt onto the second hole. Okay, and then we hang it again. Again we will have the total time taken by certain number of time periods, which we will fix as 20 in this case. Again we will measure the length and the time taken. We will divide that by the total number of oscillations to obtain the time period for that length. And similarly, we will keep changing the length using these holes, and we will keep recording the time period. Okay, so that is from one side And once you had actually done that along the one side, what we will do, we will simply flip actually this, okay, and then we will start performing the same experiment again, starting from the first hole, hang it with respect to the first hole, find out the time period after measuring the length, second hole, third, fourth, fifth, sixth, 7, 8, 9, 10, 11, etc., etc., and that would fill the whole table. So let me show you the table which is here, and that's in fact that's the that will give you in fact the total readings. So you could see here is the table that you need to fill. Now let me tell you, before measuring anything with any measuring device, you should first record its least count, right? So for example, here you got the meter scale, and let's see, this meter scale has some least count over here. So usually it is written, so this is in centimeters, so this is 100 centimeter, and every centimeter is divided into 10 equal divisions. So that means its least count is 0.1 centimeter, which is 1 millimeter. Okay, so you should note down that thing. Also, we must note down the least count of the stopwatch, which we will be using to record time. In fact, you could see over here, it says the least count is 1/100 second, that is 0.01 second. So that is the lowest reading that our stopwatch could record. Okay, so we should be in fact noting down all those things. Now let's come to the table of observation, or the observation table. So it says distance of point of suspension with respect to knife edge from one end in centimeters. So as you remember, I had measured the length 36.2. Similarly, it will keep decreasing and so on. Then the time for oscillations, set 1. That is from one side. Then you flip, you will get another set. So you fix the number of oscillations to 20 and then keep recording the time taken. Okay, take the average and then take the average, divide that by 20, which is the total number of oscillations for which you are performing the experiment. Now keep decreasing the length, keep recording the value, set 1, set 2, mean for a given length, and find the time period. Okay, so this is what you do. Obviously you would notice that as the length changes, time period would change, because ultimately G is a constant, right? So now what we will do, the next step is to make a plot between the time period, as you could see on the y-axis, which you had obtained actually through the table, and the length, as you could see. Okay, so this is how you do one set of reading, another set of reading. Okay, and then what we will do, we will measure these lengths after creating this plot. Okay, so we will measure AG, which is the length L1, BG, which is length L2. Similarly, on the other side, you have GC as the length L2 and GD is the length L1. So now your plot is complete. You had recorded these four readings, L1, L2 on one side, L1, L2 on the other side. So let's see what else remains. We will calculate total L, capital L. L1 is AG is equal to GD, L2 is BG is GC. If there is difference, what you could do is essentially you could take the mean, and that would be your L1, mean L2. Then capital L is L1 plus L2, which is AC plus BD by 2, and now you got the length capital L. And you also know the time period corresponding to that, isn't it? So that time period, let me just show you over here itself. This is the time period that you need to record. Okay, so you have got the value of L capital and you have got the value of T capital. So let's put all those things into the formula. See, it says over here T is OH square. So let me check the plot. Let me show you the plot again to show where is the OH. OH is essentially this height, you could see, this site over here, OH, right? So this is the time period with respect to CG to G. Okay, so after you put these values, you would get the value of acceleration due to the gravity at the location of the lab. Okay, now what you could do, you should be, in fact, when you write your experiments properly into practical notebook, you should not only record the value of G over here, rather you should also tell us the standard value of G that you could find through the internet, and now you should calculate the percentage error between the two. So this is how you will be able to complete your experiment. We will supply you the observation table and of course this manual. All you need to do is to perform these calculations in each and every experiment. Okay, hopefully this is clear, and now I would like you to complete all these things using the observation tables we supply and obtain the results, the errors associated with it, write these things neatly and cleanly and submit it via the classroom where we expect these things to be submitted. Okay, so this completes the experiment. Thanks a lot.